I am Tangashakti from AAA Department, Rohini College of Engineering and Technology. In this lecture, we are going to discuss about analog filter design. Chebyshev filter. So the Chebyshev filters are analog or digital filters. It's having the characteristics steeper. It's having steeper than Butterworth filter. And it's also have pass band ripple or stop band ripple. So this type of filter is derived from the mathematical characteristics of the Chebyshev polynomial. So its name will be Chebyshev filter. So this is the characteristics of the Chebyshev filter. So now we are going to discuss about the design procedure for low pass digital Chebyshev IR filter. So here we have some specifications, that is first one, pass band edge digital frequency. Its unit will be radian per sample. Next one, omega s is the stop band edge digital frequency in radian per sample, and here t. So t is nothing but the sampling time. The unit will be seconds. So we can tell t equal to 1 by f of s. Here f of s is the sampling frequency. So the sampling frequency unit will be hertz. Next AP. So this is the gain at a pass band frequency omega p, and AS is the gain at a stop band frequency omega s. So here first step, we have to choose either bilinear or impulse invariant transformation. So bilinear or impulse invariant transformation is the frequency transformation. It converts from digital to the analog frequency. So here first we have to determine the specifications of the equivalent analog filter. So here OMP, so this is the pass band edge analog frequency corresponding to omega p, and OMS is the stop band edge analog frequency corresponding to omega p. So with the help of bilinear transformation, we are converting the stop band, pass band digital frequency into the corresponding analog frequency. So for the bilinear transformation, we have separate formula, OMP equal to 2 by t tan omega p by 2, and OMS equal to 2 by t tan omega s by 2. For the impulse invariant transformation, we have separate formula, OMP equal to omega p by t, and the digital stop band digital frequency equal to stop band analog frequency divided by 2 t. So next step, we have to determine the order n of the filter. So in order to determine the order n, first we have to calculate the parameters n1. So always the order n should be greater than or equal to the parameter n1. So for calculating the parameter n1, we have separate formula, cos h inverse square root of 1 by a s square minus 1 divided by 1 by a p square minus 1 divided by cos h inverse ohm s by ohm p. This is the formula for the parameter n1. So next is step 3. So for this step 3, we have to calculate the normalized transfer function h of s of n. So the n represents this the normalized transfer function of the filter. So for the normalized transfer function, we have separate formula, h of s of n equal to pi k equal to 1 n by 2 b suffix k divided by sn square plus bk sn plus ck. So if the order n, we have calculated the order of the filter. So if this order will be odd, means we have separate formulas. H of s will be like this, b suffix non divided by s plus c non, pi k equal to 1 n minus 1 by 2 bk divided by s square plus bks plus ck. So these are the separate formula. So for all the parameters bk, ck and c non, we have the formulas. If the value of n, the order of the n will be even value means we have separate formula. Next, we have to determine the unnormalized analog filter, analog transfer function H of S. So, in the previous step, we have calculated the normalized analog transfer function. Now, we are going to calculate the unnormalized analog transformation. So, here we have some formulas. H of S equal to H of S of N. So, here S, we have to convert. We have to substitute Sn by S by Omc. So here if the order n is even means we can obtain H of S by substituting Sn by S by Omc. If the order of the filter odd means we have to calculate H of S by substituting Sn. So after this we have to calculate the transfer function of the digital filter H of Z. Next, the digital filter transfer function H of Z can be realized with the help of some suitable structure. For the filters, we have direct form, cascade, direct form 1-2 structure like this. So with the help of, by using any one suitable structure, we can realize the H of Z. Next, we verify the design by sketching the frequency response. H of E j omega equal to H of Z at Z equal to e power j omega. Next, so this is the filter design for the low pass filter. So next, if we want to calculate for high pass, band pass or band stop filter means from the low pass filter we can implementing the corresponding frequency transformation, we can calculate high pass, band pass and band stop filter design. Thank you.